the project demonstration of my Accelerator final project of the electromagnetic fields class. So in this project, I was given the opportunity to basically simulate a particle accelerator environment using the mechanical motion of a proton. So I've I've tried to use MATLAB in this whole process because it has the perfect tools that I can use to simulate. And in the very first step, let us see a simple mechanical motion of a proton where it is placed between two extreme charges, one being positive and negative, with a certain distance. So let us see how it goes. I'll go to MATLAB and this is the proton simulator code that I wrote. So it will take a couple of inputs from the users, and then there is a certain animation which basically displays the two charges in the graph. The positive being at 0, 0 coordinate of the graph, and then the rest of information we are supposed to enter as users. So let me run this for a quick simulation. So the first thing it has asks is the what is the total charge, the magnitude of the charges. So let us say it is 10 to the power -6. I'm taking small charges for now. And what is the distance between those two charges? And let's say they're placed 10 centimeters, which is 0.1 meters apart. So what is the distance between plus Q and test charge? So the test charge is the proton here, right? And plus Q is placed at the 0, 0 coordinate. So let's say the distance between them is around like 5 centimeters, which is 0.05. And then the time step interval. So time step interval is basically like how much time like at each step it takes to go in the trajectory. And let's say it is 10 to the power -10, and let's see what it got. Okay. As you can see, the proton starts to move away from the positive charge here, which is placed at 0, 0, and this one's the negative charge at 0.1. And so this is the current trajectory of the proton. In this case, we can also see the path of the proton in y direction versus the time. So this is the time step. So the distance in the y-axis, it reduces with time, because as you see, it's going in the negative y direction. The distance is being reduced. And um, if I talk about the proton angle, so the angle I gave in the code is around like 45 degrees. It starts at 45 degrees. And then from 45, as you can see, with each time step, the angle is being decreased, and it is more to do with the setup. What kind of charges we put, what is the polarity of the charges. And so yeah, the angle basically decreases. And we can actually test different aspects of it. So what I've done here is basically, so I put all the equations here, and now let us see if we put a negative charge for the test charge. So let us run this again. So let me put 10 to the power, so -10 to the power -6. Okay, my bad. To the power -6, and the distance remains the same, 10 centimeters apart, and let's say 5 centimeters here. And then each time interval is 10 to the power -10. So yeah, as you can see, if it is the test charge with like a negative charge, so what happens here is that it is mostly so not the test charge, I mean, sorry, these charges which are placed in the coordinates, if they are being if it's being, this one is being changed to negative, so the positive proton is being attracted to the negative charge which is here. And then you can see the trajectory of it here. Yeah, my bad. I guess I explained it in a different way. The negative test charge, the negative charge is for this particular charge, which is at 0, comma 0. So yeah, and these are the change in angle and the change in y position of the proton in accordance to the time. So let us try one more criteria and then move on to the next aspect of it, which is actually, so let me um yeah, let me run this again. So let's say we'll put 10 to the power uh, negative 6 back again, and uh, 10 centimeters apart. And now let me put the charge exactly in between both the charges and see how the proton trajectory changes. And 20 to the power negative 10. So, okay. So as you can see, the proton is again like moving towards the negative charge. It travels in this particular trajectory, and it basically comes here and then again goes back because it is placed exactly in the middle. So as it as it moves forward to the positive charge, it again ripples back and goes back to its original position. So here you can see the again the change in position and change in angle with respect to time of the proton trajectory. And I guess this gives a sort of easy understanding of how a proton behaves in between two charges. We can change the polarity of both the charges and play around with it for more learning. And as I will also attach the code in the YouTube description and as well as in Canvas, so that you guys and of course Dr. Joy can like test it and see if it works, if everything works well. So let's actually move forward to the next aspect of the project, which is the circular ring, right? So this is the code for the circular ring. Here I've used like a particular animation to basically simulate, a circle diagram with a radius around the graph in MATLAB, and let's see what happens here. Yeah, let me run this. Just one sec. I want to make sure if this is being recorded or not. Yeah, it's being recorded. Yeah. So yeah, let me run this. Okay. So the first thing it asks as the input is the mass of the proton, the test proton, and let's say it is 1.67 e to the power negative 27, and this is basically by default. And what is the total charge of the ring? So let's say the ring is a positive 10 to the power, I mean, yeah, 1e negative 6. And what is the radius of the ring? Let's say it's not big. Let's say it's 10 centimeters, 0.1. And what is the z position of the protons? So let's say the z position is, let's keep it kind of minimal, 0.05. So in this particular aspect of the project, so we have three coordinates, the x, y, and z coordinate. The the circular ring basically, in accordance to my code, is placed in the xy coordinates of it, and the proton is being like it is multi dimensional. I'm basically placing it at xyz axis, and I'm giving like a little a little up, 5 centimeter up to it, and I'm placing it 5 centimeters up in the z axis. And yeah, let's see how the proton behaves in the circular ring. Okay. So for better viewing, I'll take a 3D aspect of this. And as you can see, yeah, as you can see, the proton is moving away. I'll just show you all in all directions, and you can see the proton actually moving away from the circular ring, a positive ring of charges here. And yeah, so basically this is the simulation for this particular aspect of the project, and you can see the positive proton is being moved away from these positive ring of charges here, and we can also see it in the graphs. So this is as you know, it is moving away from the circular ring, so you can see that it increases it increases its value in the z direction as it moves in the positive z direction. So the z position increases with time, and the next graph being the velocity, and of course the velocity is also being increased as it moves away from the circular ring influence. And the acceleration, right? Yeah, I guess as velocity even more, like it's increasing at one point, it acceleration increases, and one point it again starts decreasing. So this is the second aspect of our project, and again you can find the code link to test it around. So let's actually go to the third part, which is placing the proton in the influence of a cylinder. So I think I've got this code